take proactive measures to avoid collisions, navigate dangerous waters safely, and respond to emergencies effectively. By acting as a watchful guardian at sea, AI contributes significantly to the safety of the crew, cargo, and the marine environment. Beyond safety, AI also plays a crucial role in optimizing the operational efficiency of smart ships. By analyzing data from various onboard systems, AI algorithms can identify inefficiencies and recommend adjustments to improve fuel consumption, reduce emissions, and minimize operational costs. For instance, AI can optimize engine performance by analyzing fuel consumption, exhaust temperatures, and other engine parameters. This allows for real-time adjustments to fuel injection, air intake, and other engine settings to ensure optimal combustion and minimize fuel waste. Similarly, AI can optimize the ship's speed and route based on factors like weather conditions, ocean currents, and cargo weight to reduce drag, save fuel, and minimize travel time. Furthermore, AI can streamline cargo loading and unloading processes, optimize ballast water management, and even automate routine maintenance tasks. These intelligent automation capabilities not only improve efficiency, but also free up the crew to focus on more complex tasks that require human expertise. By optimizing various aspects of ship operation, AI contributes to smoother sailing, reduced costs, and a smaller environmental footprint for the maritime industry. The concept of smart ships is rapidly transitioning from theory to reality, with several real-world applications already making waves in the maritime industry. Leading shipping companies and shipbuilders are investing heavily in AI-powered technologies to enhance their fleets and gain a competitive edge in the global market. One notable example is the development of autonomous ships, where AI takes complete control of navigation, engine management, and cargo handling. While fully autonomous ships are still under development, several companies are already testing and deploying partially autonomous vessels for specific tasks like harbor maneuvering, short-distance cargo transport, and oceanographic research. Another prominent application of AI in marine engineering is in predictive maintenance. By analyzing sensor data and historical maintenance records, AI algorithms can predict potential equipment failures before they occur. This allows for proactive maintenance scheduling, minimizing downtime, reducing repair costs, and preventing costly disruptions to shipping schedules. As AI technology continues to advance, we can expect to see even more innovative applications of smart ships in the near future. The integration of artificial intelligence in marine engineering is revolutionizing the way ships are designed, operated, and maintained. Smart ships, powered by sophisticated AI systems, promise a future of safer, cleaner, and more efficient maritime transportation. From optimizing navigation and enhancing safety protocols to improving fuel efficiency and automating routine tasks, AI is transforming the maritime industry in unprecedented ways. As the technology continues to evolve, we can expect to see even more innovative applications of AI in the maritime sector, leading to greater automation, improved sustainability, and a reduced environmental impact. The journey towards fully autonomous AI-powered ships is still ongoing, but the progress made so far is a testament to the transformative power of AI in marine engineering. As we chart a course for AI-powered seas, the future of maritime transportation looks brighter, smarter, and more efficient than ever.